Right, so let's talk about the hypothesis test and R-squares. In the last lesson, we described sales price and mileage data for ABC's podcast by finding a regression line that best describes the data. So how do we know if the regression line is significant, and how can we tell how well this line uh, describes the data? To determine the statistical significance of the equation, we can conduct a hypothesis test. In regression, the hypothesis test the slope of the equation. We use B1 for the slope of the last squares regression line. We will test whether the true slope B1 is equal to 0. If the line is flat, the slope is 0 and no linear relationship exists between the variables. But if the line is not flat, the slope is not 0 and a relationship may exist between variables. So what does this mean for the sales price and mileage data? If the null hypothesis states that the slope equals 0, we are stating that mileage is not linear related to sales price. In other words, sales price is the same no matter what the mileage. For the sales price and mileage data, the alternative hypothesis is that mileage is related to sales. The mean sales price is different depending on the mileage. After we have stated our hypothesis, we can perform the regression analysis. Here is the output for the analysis. The regression equation is the same we saw earlier. Next, look at the analysis of variance table. So let's focus on the p-value. P-value. When there is one explanatory variable, this p-value tells us whether we can reject the null hypothesis and conclude that the slope is not equal to 0. First, we need to choose the significance level or unfair level appropriate for our situation. A common answer is 0.05. 0.05. So we'll use that if the p-value is less than or equal to unfair, we reject the null hypothesis that the slope equals 0. And if the p-value is greater than unfair, we fail to reject the null hypothesis. Based on these test results, should we reject or fail to reject the null hypothesis? Because the p-value is less than 0.05, we reject the null hypothesis and conclude that mileage is related to sales price. After we know that the relationship between the variables is statistically significant, we can determine how well the response is explained by the explanatory variable. If the explanatory variable explains much of the variation in the response, the points on the plot are close to the regression line. The residuals are small. So if the explanatory variable only explains a small amount of the variation in the response, the points are farther from the regression line. The residuals are larger. To measure how much variability in the response is explained by the explanatory variable, we can use we can use r square. R square is a value between 0 and 1 and is usually expressed as a percentage to make it easier to interpret. As a percentage, R square is value between 0 and 100%. As the points get closer to the regression line, the R square value increases. When R square equals 1, all of the points fall directly on the regression line, and the explanatory variable perfectly explains variation in the response. So as the points get farther from the line, the R square value decreases. Here is the fitted line plot for ABC example. The fitted line plot gives us the regression equation as well as the R square. The R square value is 0.795 of 79.5%. The R square value is the correlation coefficient squared. Remember that the correlation between mileage and sales price is J minus 892. The square is of minus minus 0.892 is 0.795. This value means that the mileage explains 79.5% of the variation in the sales price. Just as with the correlation coefficient, we have no general rules to help us determine how well this regression fits the data. The interpretation of R squared depends on the application. Aside from mileage of a car, other factors such as condition of the car or its color may also influence the sales price of the product. However, the moderately high R-square value indicates that the mileage alone greatly affects the sales prices. So let's review. Remember that to determine whether the explanatory variable is related to the response variable, we can conduct a hypothesis test of the slope. The null hypothesis states that the slope equals 0. The alternative hypothesis states that the slope does not equal 0. If the p-value for the test is less than alpha, we reject the null hypothesis and conclude that the explanatory variable is significantly related to the response variable. The R-square value quantifies how well the regression line fits the points and indicates how much variation in the response variable is explained by the explanatory variable. Thank you for your listening. In the next lesson, we'll talk about the assumptions and residual plots.